Okay, so all I did was read the problem for anyone on YouTube catching up. Basically, what we need to do is we're going from revolutions per minute, and we need to get that into miles per hour. So the minute I know that what was given to me is not the same like units of what I want at the end, I got to do some kind of conversions. Now at this point, I'd be like, oh, I don't know anything about revolutions. I've got to use our common sense. I've got to use what we know about the tire though. It tells me that we know the tire's diameter. So let's just draw a little circle. This is the tire. Its diameter goes all the way through the middle, right? We want to do a revolution. So if I start on one point on the circle and I go all the way around it, that's one revolution. What's that also the same thing as? The perimeter. And what do we call perimeter in a circle? Circumference. Good. So circumference is going to be the same as one revolution. Reminder, circumference is either 2 pi r, or another way to write it, which I think is super relevant here, is pi times d, pi times diameter. Anyone lose a metal thing? Okay, let's just gonna stay on the floor. Pi d is actually the most helpful thing because I already gave you diameter. So we're taking all of the diameters I just gave you and we're multiplying them by pi to figure out how many inches it is for one revolution, what its circumference is. So I'm gonna take all of those and multiply them by pi. I remember just the other day I have this built-in calculator, so I'm gonna use that so you guys can see what I'm doing. Yep, I'm gonna take each one of those. So I'm gonna do 26.16. I'm gonna multiply that by pi. So my first circumference is going to be 82.18. Mine is if I do second caret, the button above the division sign. Yep. And remember, like we said, that's our circumference, or what we said is one revolution. All right, I'm going to keep doing that. 28.63 times pi, I get 89.94. New colors for proof point. $89.94.
Okay, so the first one we did 26.16 times 5.
Yep. And the second one I just did was 28.63 times 5. And now I'm about to do 28.95 times 5. $90.95 inches is one revolution. One rev. All right, so now that we have that, we're going to set up our conversion. We're going to do our math problem. We are going to do this 3 times, but we only need to write it 1 time because I'm only changing this right here each time. Everything else is going to be the same. This is the only thing that will ever change. So let's think about what that is. They gave us 8 revolutions per minute, so that's where we need to start. I'm going to start with 8 revolutions per minute. $800. Why did I say 8? 800 revolutions in 1 minute. I know conversions can be taught a little differently. I had a really old school chemistry teacher that we did this like train track kind of thing. This is how I do it. Whatever you want to do it, however you want to set it up, go for it. Okay, I think the next easiest thing is we want to go from revolutions over minutes to miles per hour. So let's get that minutes into hours. That's easy, right? How many minutes are in 1 hour? 60? I want the 60 to go on top because I want to opposite the minutes that I have on the bottom. The minutes are going to cancel. And so I've got 1 hour on the bottom, 60 minutes is on top. All right, great. I want to end an hour, so that is good. I don't need to do anything else with this hours. But now I need to get revolutions into miles. The whole reason we use the chart, the whole reason the chart was given to us is that's telling us revolutions in inches. So like the first one, the pink one, it says 82.18 inches equals 1 revolution. That's the next step I want to use because I need to cancel this revolution. That's what I started with. I'm going to put my 1 revolution on the bottom and I'm going to put my inches on top. I'm going to put my 82.18 inches on top. All right, so my revolutions cancel, and now I need to go from inches to miles. We can do that. Can you do inches into feet? How many inches in 1 foot? Good. So my inches cancel, 1 foot. And then we need feet into miles. Do you remember how many feet are in 1 mile? I think it's 280. 5,280. So feet. And now my last units, I cross everything out except I have hours on the bottom and miles on top, which is exactly what I want. I'm now going to go throw this into the calculator. Again, everyone does it a little differently. I had an older calculator that wasn't as smart as yours is, but I'm going to multiply everything on top. I'm going to do 800 times 60 times 82.18. No need to multiply by 1, no need to multiply by 1. Then I'm going to press enter, and then every time I have another number in the bottom, I'm going to divide that number, enter, divide that number, enter. I don't need to divide by 1s, that doesn't do anything. So the first real number I have to divide by is 12, and then the next real number I'm dividing by is 5,280. All right, this is where we do our common sense check. So I asked myself, okay, my answer is 62.26 miles per hour. Does that make sense? Can your car go 62.26 miles per hour? Yeah. Some of you already have driven that fast this morning, right? Probably. Okay. But so if we had gotten like 500, I would have been like, whoa, I don't think my car can go that fast. But 62, we all go that pretty regularly. So that's good. Okay, we're going to do the exact same thing, but now I'm going to plug in the 2 other numbers. Everything else stays the same. Even though I'm looking at a new tire, minutes per hour is still the same. Feet into miles is still the same. Inches into feet is still the same. The only thing that I'm going to change is I'm going to take out my first revs, inches per revs. I'm trying to change my color so it looks good. I want to get rid of that 82.18. And I'm going to put in 89.94. Everything else stays the same. We're just going to see what our answer is here. And then once you're done with that, we'll plug in 90.95 and see what our answer is too. We're going to do all 3 for this one. Sometimes I might just give you 1 example, but this time I want us to do all 3. What's different? Yeah, the reason we're doing all 3 is because I gave us all 3 and because they all have different circumferences, they'll all have slightly different miles per hour. But if I just had like 1 car, so if I was like, okay, I personally drive a CX-5 and I was like, I want to know how fast I'm going, then we just do it 1 time. But we have 3 tires, so we're doing it 3 times.
So after we put birds and all that stuff, you have to put in all 3 of the diameter, and then that, and once our answer, each 3 of the same.
Those 3 speeds are going to be our answers. So in the first, with the first tire, the Ford Taurus tire, you would be going 62.26 miles an hour when you're doing 800 revolutions. In the second car, I think it's a Dodge Charger. If I'm doing 800 revolutions per minute, then that means I'm going 68.14 miles per hour. The only thing you're changing is the inches per rev. So I did the pink one, I did the green one, and now I'm about to do the purple one, 90.95 inches. The Dodge, I got 68.14. All right, and you could rewrite that conversion each time, but I'm gonna argue you don't need to. Nothing else changes besides that middle thing that we changed 3 times. Everything else stays the same. So I just have my 3 different answers. I actually don't even want to do letter B. I just wanted to do letter A. I wanted to just practice some conversions. And I don't even want to do letter I on the next page just for sake of time. I just want to keep moving. At this point, you have done all of 4.1, so that homework is due next time I see you, which is Monday. So you have 4.1 homework due on Monday.
When there's NWEA, do we know how school?
No, you have school, it's just comes, it's in the morning. So like Monday is
so later.
NWEA testing. So like sophomores and freshmen will come in at like 7:45. You just don't start school till 1 more time.
Oh,
You guys don't have the NWEA. All right, you guys ready to move on to 4.2? All right, we're actually gonna start 4.2 on your unit circle sheet, and I want you to turn it over to the back. I want to use the back sheet as that. Now, I don't know if you remember, but I was most of your guys' geometry teacher 2 years ago when the global pandemic began. Do you remember that?
yeah.
Vaguely. I don't know why I put in geometry. When that happened, we were kind of, I think, in this trig unit. And so I'm gonna act like you don't remember anything. If you do remember things, that's amazing. But I do remember teaching some of this online. So if you do not remember it, I do want you to tell me. I want you to act like you don't know it. I really want to like focus on this stuff because this is so important. Okay.
That's right.
So on the back side, I would write basic trig functions and I'd make like a little 6-box grid. I'm erasing all the things I'm gonna fill in. I just don't want to start from the beginning. So. And once you've kind of set yourself up with your basic trig functions, a little grid, I want you to draw a triangle next to it, a right triangle. And then put a theta in one of the angles. I like the bottom left one, but you can put your theta wherever makes you happy. All right. The other thing I want to write before we do anything is this. If my pen wants to write, that'd be great. I promise I'm not this messy. It's my pen's being a little weird today. All right, so Toa. Does that mean anything to some of you? Yeah, you're like, oh, I've heard it. Rings a bell. Then the letters mean something, right? So I teach you SOHCAHTOA because that's a way to remember the 3 most basic trig functions and their ratios. Trig functions are all ratios and they're based on a triangle. So we put an angle in one of the acute angles. We've always, at this point, we've only done the acute angles of a right triangle. The side across from that angle is what we call the opposite side. The side across from the right angle, you guys know this one? Good, hypotenuse. And then the third side, I think, is the hardest of the 3. It's not hard, it's just not the most obvious one. It's the adjacent side, and it's not the opposite, and it's not the hypotenuse. It's the adjacent side. Okay. I wrote SOHCAHTOA first because that's gonna help us remember it. The S and the C and the T all refer to sine, cosine, tangent. So that's the function that we're using. The O, H, and A all refer to the sides, opposite, adjacent, and hypotenuse. So the first one, so, is for sine. Sine is opposite over hypotenuse. So I'm gonna come over here in my little grid and I'm gonna write sine of theta because it's sine of the angle equals opposite over hypotenuse. Sine of that angle is whatever the opposite over the hypotenuse is. All right, cosine is c, so that's going to be A over H. Cosine of theta is A over H. I didn't write these in the other class, but I'll write them here. Sine is S-I-N-E. I know we go to Catholic school, but it's not sin, it's sine. When I taught at public school, no one ever called it sin. And then I came here and I was like, oh, you guys just talk about sin all the time, right? And then the other one is cosine. But everyone will be like, oh, the sine is, the sin is this. And I'm like, no, sine, 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 sine. And the last one is tangent. I'm just writing like the full words out because I won't write them a lot. I usually just will write like the shortened version of sine, cosine, and tangent, even though I say all of it out. And my tangent of theta is TOA, which is opposite over adjacent. All right, even if you don't remember it, I definitely, at least if I wasn't your geometry teacher taught you this at some point. Again, I think it was right when everything fell apart, so I assume we don't remember this, so that's why I'm going over it. What you do not know, what's new to you today, is the reciprocal functions that go with them. So each of them has a partner function, which is just the flip, the reciprocal of their ratio. So the one that goes with sine, we abbreviate as CSC theta, and that function is called cosecant. Cosecant. If sine was opposite over hypotenuse, cosecant is hypotenuse over opposite. The opposite for cosine is secant, and we abbreviate that SEC theta. If cosine was adjacent over hypotenuse, its flip is hypotenuse over adjacent. All right, secant off to the side. And then the last one, I think makes a lot of sense with tangent is cotangent, COT. And cotangent of theta is the opposite of, it's the reciprocal of tangent, it's A over O. When I put these on your notes or your homework, I will set you up like this so you don't have to second guess which ones go with which. But in order to start remembering which ones go together, tan and cotangent go together. I think those are easy, it makes sense. The other ones, you probably want cosine to go with cosecant, right? Because the cos, you're like, oh, the cos should go together. Each one of them gets, sine and cosine both get the opposite of what it is. So sine goes with cosecant because you need a co with it, and then cosine goes with secant. I just remember it, it's opposite of what I want. I want the cosines to go together. I want both of the s's to go together. It's not what I want, it's opposite of that. So that's how this works. All right, I think that's enough for right now. Anybody have any questions yet? When you're done with this, I want to jump back to our notes because I want to do problems on that using just our sine, cosine, tangent, all that fun stuff. But I did want to review this before and I wanted to make sure you had plenty of space to write it. So let's jump back into our notes. And we're going to do all of number 1 and 2, and then we're going to go back to our unit circle sheet. Okay. So this first one says, find the value of all 6 trig functions of theta, and it gives us this triangle right here. Okay. I've got my angle here. Cool. Every time I see a triangle, I'm going to start labeling the sides that I have. So what side do I have? 5. Good. What's 5 called? Good. My hypotenuse. What other side do I have? Opposite. Very good. What side do I not have? Adjacent. Good. In order to do anything though, we need to find adjacent. Do you remember how to find that missing side of a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. Welcome to your best friend for the rest of this chapter. There are gonna be so many times that we're gonna do something that I'm gonna be like Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. Don't forget about him, he's your best friend. All right, so just a quick reminder, if you haven't done Pythagorean theorem for a while, which is the only letter that always goes in the same place? C, where does C go? It always equals C squared. Where on this picture am I gonna write C? It's always my hypotenuse. Always my hypotenuse. It does not matter where A and B go. One of them is one leg, one of them's the other leg. It doesn't matter, but C is always the hypotenuse. So make sure he always goes there. All right, so I'm gonna plug it in. I'm gonna say, okay, I got 2 squared plus B squared equals 5 squared. 2 squared is 4 plus B squared equals 25. Minus my 4 from both sides, B squared equals 21. Square root B equals square root of 21. Bless you. There's 21. If we can simplify that, I would like us to do that. We cannot do that here. Square root of 21 is just 3 and 7, but you can't take anything out. It doesn't simplify. Okay. Anybody, any questions on finding that third side? All right, now we're gonna put it in my ratios, okay? So sine, we know, and if you forgot, I might write it here. I'm gonna say, okay, sine was opposite, bless you, over adjacent. And my opposite is 2. Oh no, what am I doing? Sine is what? Opposite over hypotenuse. I'm tripping. 2 over 5, there we go. Cosine is adjacent over hypotenuse. We just found my adjacent is root 21 over 5. And then tangent is opposite over adjacent. That is going to be 2 over root 21. Now, in a minute, I'm going to make you rationalize. Right now, you do not have to if you do not want to. I think it looks nicer if we do, but right now, for these problems, I will not make you rationalize if you don't want to. Remember, rationalize means I cannot have that square root in the bottom. So I can make that 2 root 21 over 21 instead of leaving it as 2 over root 21. Again, right now, I will not make you do that, but I'm going to do it. I'm going to show the best method. So these are all my answers for sine and cosine and tangent. Now, all of them are just reversed. They're all flipped. They're all reciprocals for the next one. So I'm just going to look at my sine, and cosecant is just going to be 5 over 2. Secant is going to be 5 over root 21, which I will rationalize just to make it look pretty. And then cotangent, it's actually kind of nice to write it not rationalized before I rationalize it because it's going to be easy to flip. That just becomes root 21 over 2. All right. Those are my answers here. Anybody, any questions yet? All right, let's do another one. This one, here's my angle. What sides do I have? Good, I've got my opposite and I've got my adjacent, and I do not have my hypotenuse, so we need to find that. Which variable is that going to be in my Pythagorean theorem? C, very good. So I'll say, okay, 3 squared plus 5 squared equals C squared. 9 plus 25 equals C squared. We've gotten really lucky. We haven't had any like radicals that we have to simplify. They've all been pretty self-explanatory. unsimplifiable. That's pretty nice. Well, it's just like more work if we have to simplify it, right? So it's kind of nice to be like, oh, I can't do anything, so I get to just move on. All right, let's put it into our functions. Who can tell me what sine is gonna be? Where's your opposite? Good, 3 over square root of 34. I put the angle in a weird spot this time, so make sure you know exactly where your angle is. Good, 3 over square root of 34. Again, feel free or not to rationalize or not. Who's got cosine? 5 over root 34. What about tangent? 3 over 5. All right, and then we go across and we just do all of our reciprocals. What's cosecant gonna be? Good, root 34 over 3. What about secant? Awesome, thank you. And then cotangent is 5 over 3. Right. All right, any questions yet? We got 2 more before we're gonna go back to the unit circle. And these are very similar to the 2 that we just did. It's just now I gave it to you, I gave your numbers to you in the trig function. So I gave you one of the trig functions already. So for 2a, I told you what secant is. Can you remind me what secant is in terms of opposites and adjacents and hypotenuses? It's the opposite of cosine. So what is the opposite of cosine? That's helpful to me because now I'm going to go to my picture and I'm going to go label it like this. I'm going to go make sure 3 is my hypotenuse and 2 is my adjacent. And I actually gave us a picture, so that's nice. Hypotenuse is across here, so that's 3. Opposite is across from my theta, so adjacent is next to it. Let me write my number or my letters next to it, H and O and A. What now? We gotta find, oh, we gotta find that missing side. Like that. 2 squared plus b squared equals 3 squared. All right. Once you have that, then you can start plugging in for your sine, cosine, tangents. I'll write mine. You guys can write yours and then check it in 1 second. Right. Thoughts, questions, concerns? I'm gonna help you set up the next one, and then I want you to do it all on your own. The reason I want to help set you up because we don't have a picture here. So the biggest thing in geometry especially, but now that we're in trig with Crucial, if you don't have a picture, I would really draw one. A lot of times drawing is so helpful. So I'm gonna draw a picture that shows me that tangent is 4/5. Before I do that, tangent is what over what again? Good, opposite over adjacent. So when I draw my triangle, and you can draw your triangle however you want, I am probably gonna draw it just like the one above it was. I'm gonna draw it like on a little coordinate plane because we're gonna get super into that in a few days, if not today. My theta is down here. Opposite is 4. Adjacent is 5. And we want to find hypotenuse. I am going to do the work, so you can check in with me, but I'm going to shut up for a little bit. I want you to try and work through it, okay? All right, here's on my work. Double check it. All right, questions, concerns? Once you have that done, you can actually put your notes away for today. We're going to finish the rest of today on the unit circle. We will not finish the unit circle, but that's going to take the rest of the class time. I got root 41. Mhm. We're going to start on the front side. I think I've done this in a different order almost every class, but I think I like doing something first and then coming to the back side. I'm just erasing it so I can be all ready to go when it's time to do this. And if you are not already, I would highly encourage you to use a pencil on this because you may mess up and it's going to be frustrating. I have extra copies if you mess up, but it'll be frustrating if you're writing in pen or marker and then you're like, oh, shoot, I got all of this wrong. So I'd use a pencil. And I think the sharpened ones are in the back. I don't think the ones up here are sharpened. So those in the back should be sharpened. You're welcome. So we could do yours unpunished, right, Callie? All right, we're gonna start with the quadrants. We call these quadrant angles. And let's actually remind me, what is quadrant 1, 2, 3, 4? I know we reviewed this the other day in class. Where do I start? Good, I'm gonna start in quadrant 1 is the top right quadrant. So I'm gonna literally write that on my paper, just in case I forget. It might feel dumb, but you might later be like, oh shoot, I messed up because I just wasn't thinking. Quadrant 1, we'll make this one quadrant 2. Let me try a little harder to write nicer. Quadrant 3 is bottom left. And quadrant 4 is bottom right. Okay, well, like a little OCD about that, but I just like have to move on. So, okay, those are my quadrants. The ones that are on the like axes are special angles as well. Remember when we did bearing the other day and I said, okay, everything is in reference to north. Things now are not in reference to north, but it's similar to that, that we always start in one place. We are always starting on the positive x-axis. So you can think of this, I might even physically write positive x-axis. We always, always, always start there. And to show that, I'm gonna put 0 degrees as my starting point. So if I didn't go anywhere, it's 0 degrees. I think we should like Noah. This is kind of important. No, I just don't want you to miss it, okay? Okay, so we're starting at 0 degrees. The first line that has a little degree sign is going to be for our degrees, obviously. The little line next to it is for your radians, okay? So every time we do a degrees, we're going to convert it into radians. How many radians is 0 degrees? 0. 0 times anything is 0. So I'm going to put 0 on that line. If it makes you happy, you can write radians behind it, but I'm just going to know after a while that my degrees is on one part, my radians is the other part. Okay. The other thing that I'm going to do, actually, let's do all my degrees and radians, then we'll come back. When I move around this, I always start on the positive x and I always move counterclockwise. So let's move to the next axis. How many degrees will I have gone if I started on the positive x and I moved to the positive y axis? 90. Very good. So I'm going to do 90 degrees. I'm switching colors. What I would do is do it all in pencil, and then but I'm a little OCD. I would probably go back and do a color coordinate later. Or maybe you have an online version of this on your Schoology. I'd maybe put this in and color coordinate online. 90 degrees, let's make that into radians. What do I need to multiply 90 by in order to get radians? Pi over 180. The zeros cancel, 9 and 18. They both have a common factor of 9. Oh, nice. This is going to be pi over 2. Remember when we learned about radians the other day, I said a lot of times it has a pi in it. So welcome to the world of pi's. A lot of fraction work here too. Okay. Now we're at the positive y-axis and we want to go down to the negative x-axis. How many degrees is that? It's another 90, so now I've got a total of 180 degrees from where I originally started. So another 90 degrees would mean that I'm at 180 degrees. What about radians? How many radians is that? Just pi, good. I'm sorry. If you multiply by pi over 180, then the 180s would cancel and it's just left with pi. All right, now we're going another 90 degrees. So I was at the very beginning, I'm going another 90 past 180. How many degrees is that? 270. Remember, I told you that's going to just start rolling off your tongue. It's an important number now. Welcome to the rest of your life. 270. Now we can definitely convert it. We can do 270 times pi over 180, and we can figure out what that is. Let's kind of do a little pattern searching right now. If I look at my radians, I started with 0 radians. Then when I went 90 degrees, it became pi over 2 radians. So every 90 degrees is pi over 2. Pi over 2 plus pi over 2 just became 1 whole pi. So how many radians should I have now at 270? 3 pi over 2. I have 1.5 radians, 1.5 pi's. So it's going to be 3 pi over 2. You can, if you want to think about it this way, you can like erase the pi off of it. I basically had 0, and then I had 1/2, and then I had a whole. So now I'm at 3/2, 3/2. And if I go one more half, how many radians am I gonna have for the next part? 2 pi, very good. So I've gone a whole 360 now, 2 180s, so I've got 2 pi's. And our degree here, if we went all the way around the circle, that means we went 360 degrees. All right, I left it blank on each one of these because I thought it was easier to kind of do degrees and radians first. Now I want to fill in the coordinate point next to it. Each of these have a degree spot, a radian spot, and a spot for a coordinate point. This is called the unit circle. When we use unit in math, it just means one. It means 1 unit. So we're kind of on the understanding that when I go from the origin all the way out to that point, I just went 1 unit. So that point, I went over 1 and I didn't go up or down any. So that point is at the point 1 0. I went right 1 and I went up and down 0. So that point is at 1 0. Using that same logic, what would my point up at the top at 90 degrees, what would that point be called? 0 1. What about at pi and 180? Good, negative 1 0. Because I went left 1 and then I didn't go up or down any. And then what about the one at 270? 0, negative 1. Good. Work. All right, we're going to do one more set of lines today. We're going to do, I'll make these pink lines. We're going to do the 45-degree angle. So this middle one, this is exactly in between 0 and 90. So as we learned with the compass the other day, that's 45. So all of these very, very middle lines, those are all 45-degree angles. Let's do our degrees and radians really quick, and then I'm going to go to the backside so we can figure out what our coordinate point is going to be. So let's do our degrees and radians. I told you that the first one is half of 45 or half of 90, so that's 45 degrees. Let's kind of use our fraction math. If I know that 90 degrees is pi over 2, what's half of that? Pi over 4. So every 45 degrees is going to be a 1/4 or a 3/4 or something like that. So all of your 45s are going to have a denominator of 4, right, Jaden? Okay. The next 45 we've already covered, right? The next 45 is 90. So if I do another 45, we already talked about that. That's 90. We don't need to talk about them again. Let's go another 45 degrees. Where am I at now? 135. I told you a 45 was pi over 4. We went another 45 to get pi over 2. Now that I've got a third 45 degrees, what's my radian here? 3 pi over 4. Good. So again, all of these are in fourths. If I go another pi over 4, another 45 degrees, I'm at 180. I've made it to 1 whole pi. Again, I don't need to talk about that. We already have it labeled. Let's go another 45 degrees. I actually think radians is easier here. What will my radians be? 5 pi over 4. Good. I'm doing 1 and a 4th. And then if I do 180 plus 45, 225. Another 45 gets me to 3 pi over 2. It gets me to 270. And then the last 45. Wait, what did we say? What was the degree? 315. And then did we say the radian too? 7 pi over 4. Good. If you struggle with the fractions part, just kind of hold tight. Once we get all of this figured out, I'll kind of show you some tricks and tips. And you'll kind of start recognizing some patterns. So just kind of recognize maybe you're a little confused, but we'll get there eventually. Okay. Now flip your paper back over because in order to do the coordinate points, I need to remind you about the special right triangle 45, 45, 90. Now most of us like SOHCAHTOA for some reason was pretty easy for us, but this was a section in geometry that we always struggle with a little bit, the special right triangles. So one special right triangle, the one that we're going to do today is a 45, 45, 90. We are going to do another one that we can flip two ways. We'll do our 30, 60, 90. So we'll focus on the 30 degree and we'll focus on the 60 degree, but we're just going to do the 45, 45, 90 today. So I want you to draw a 45, 45, 90 degree triangle. And we're going to do sine, cosine, tangent, and all that fun stuff for that. All right, in order to do that, I need side lengths here, right? I don't care which 45 you focus on. I'm just going to focus on this one in the corner. The special thing about a 45, 45, 90 degree triangle is that if the two acute angles are both 45, then that means the legs are congruent to each other. If the acute angles are the same, then that means the sides opposite them are the same. This is basically an isosceles right triangle, which is pretty cool. You guys are like, that's why your definition of cool needs to be fixed. Yeah, we'll deal with that at another day. All right, so if they're the same, we're going to put a number with them. Okay, let's say each of these are both one. Just one. They're just one. Let's figure out what the hypotenuse is, right? Let's do some Pythagorean theorem. 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. 2 equals c squared. So root 2 equals c. All right. Everyone okay with that so far? Am I moving too fast or are we doing okay? All right, let's label opposite, adjacent, hypotenuse so then I can do sine, cosine, tangent, all that fun stuff. So opposite is one of the ones. Hypotenuse is my root 2. And adjacent is the other one. That's why it doesn't matter which 45 you're looking from. I like to look from the bottom, but you could have looked from the top one and we'll get the same answers. So sine is going to be opposite over hypotenuse, which is 1 over root 2. Now this is where I do want you to rationalize. I do want this to not be 1 over root 2. I want it to be root 2 over 2. Okay. Cosine is going to be the same thing because adjacent is the same thing as opposite. So 1 over root 2, which is root 2 over 2. And tangent is going to be 1 over 1, which is just 1. Cosecant, secant, cotangent, they all just reciprocal. So let's do that. I did meaningfully write sine as unrationalized first because it makes it an easy flip, an easy reciprocal for cosecant and secant to both be root 2. And cotangent 1 over 1 switches to 1 over 1, which is still 1. Yeah, so sine goes with cosecant, so I take sine and I just flip it to get my answer for cosecant.
Where do you do like the second, like only the first column?
I do. Why do I rationalize it? Right, we can't keep the square root in the denominator, and this is where it really matters that we don't, because this is what I want you to remember. Root 2/2 is gonna be a number that we will remember, and I want you to get used to remembering it rationalized. Just it's the most best way of writing it mathematically. Kylie, what was your question? Perfect, okay, then we're good. Okay, I made us do all of that work to just take the sine and the cosine, and we're gonna put that on the front side, okay? The whole reason we're doing this unit circle is gonna kind of come to light now. If I go back to the first side, my 45, we'll start with the normal 45. When we put this into our ordered pair, the cosine, I'll write this even off to the side. All the ordered pairs are x, y. X is your cosine. And y is our sine. So by just looking and just knowing this unit circle, I will be able to know that my cosine of 45 is √2/2, because that's what my x value is. And my y value is my, is my sine function, which is also √2/2. The other two that we're gonna do next class are not gonna be the same, but right now they are the same, and that's okay. Now, as we rotate around though, my numbers will not change, but their signs will change, okay? So let's rotate to the second quadrant. In the second quadrant, which is negative, your x or your y? X. So I still will have √2/2 for my x, but now it's negative. My y stays positive and it stays √2/2. This means though that my cosine of 135 is going to be negative √2/2. And if you don't trust me, you can put that in your calculator and that's what you would get coming out.
How do we, like, how is it routine?
Because your x is your cosine and your y is your sine. And if you go back to the back side, we just found that sine was √2/2 and that cosine was √2/2. All right, now in the third quadrant, what's negative? Both of them, so they're both negative √2/2. And the fourth quadrant, what's negative? Y, so it's gonna be positive √2/2, negative √2/2. So we have done half of this. We'll do the other half next class. But right now I could ask any of you what, let's say, what sine of 90 is. If I say what sine of 90, we go to 90 and we look at which, your x or your y? Y. Y is sine, so I'd say sine of 90 is 1. We want to get our calculator out, you could press sine of 90 and you would get 1. I could say, yes, that's going to check me right now. I could say what's cosine of 5π/4?
Wait, sine of 90,
Sine of 90, what'd you get?
89.
Okay, you are not in the right degrees. You're probably in radians.
-2√2.
Go to mode. Yeah, you're in radians. I know you guys.
What?
See? So this is a tool to help you. The cleaning bell was supposed to ring a minute ago, so we still have 4 more minutes. Your 4-1 homework is due next time I see you. We're gonna keep working on this unit circle. We're gonna keep going through 4.2 notes next class. All right, good work, guys. All right, let me stop my recording.